Very good afternoon, students. Welcome to the SBR online classes. Myself, Sandesh Deshpande, mathematics lecturer in SBR Pew College, Kalburgi. Uh, so now I'm here to uh, take one of the concept here of your syllabus, that is chapter 7, permutations and combinations, students, right? Uh, as you know, I'm revising this, right? This concept you have already done in the online class there. So now permutation and combinations, right? So as you know, the permutation, the permute word is nothing but what here? To arrange. Permute means to arrange. Permutation means arrangement. Okay. Whereas combination is nothing but what, students, here? Selection. Okay. So before going to understand this permutation and combination, one of the basic concept you have to know firstly here, right? So let me explain about what is the thing. This is a basic concept here. This is what here? Fundamental principle of counting. Before to approach the permutation and combination, firstly we have to begin with fundamental principle of counting, right? So in this basic thing, we have two rules, students. One of the thing is multiplication rule, right? Fundamental principle of uh, once again, fundamental principle of counting, right? Fundamental principle of multiplication as well as fundamental principle of addition, where we have two rules, students, right? Let us focus on this one here, right? This is the thing which is multiplication rule. It is nothing but what here? It's a multiplication rule. So what it says, just here. If an event can occur in m different ways, following which another event can occur in n different ways, then total of occurrence of the events in the given order is m into n ways, right? What actually it says here, if one of the event, that is one of the task, is occurring in m different ways, another event, right, there is another task which is falling in n different ways, then total number of events together, simultaneous occurrence of these two events together, is given as what here? M into n ways. It is given as what here, students? M into n ways. Got it? So this is a multiplication rule says, right? Let me explain you this with the example here. If suppose I have two shirts, students, if suppose I have two shirts and three pants, right? In how many ways I can wear this outfit here, right? I have to wear shirt as well as pant. In how many ways I can do this, right? So multiplication rule says you have to multiply these two things, 2 into 3, that is 6 ways, right? If this is one of the wearing a shirt, it is one of the tasks. Wearing a pant, it is another task, right? So these two tasks occurring simultaneously, students, right? So this can be done in what here? Yeah, 2 into 3, that is 6 ways I can wear this outfit here, as like this, right? Just here s1 s2, let me take s1 and s2 be the two shirts, and p1 p2 p3 be the three pants. And now what are the pace I can wear this, right? Just here I can wear the shirt 1 and pant 1, or I can wear the shirt 1 and pant 2, or I can wear the shirt 1 and pant 3, right? Or I can wear shirt 2 and pant 1. I can wear the shirt 2 and pant 2. I can wear the shirt 2 and pant 3, right? So in what are the total possible ways? There are 6 possible ways I can wear the outfits here, right? Only one outfit you will be wearing here. But what are the total possibilities here? Total possibilities are how many here? 6. So how we can know this? By this FPC rule, that is multiplication, fundamental principle of multiplication rule, right? So here we have two tasks. You can have more than two tasks also, right? If I say if I have two shirts, two pants, and four ties, right? Four tie. In how many ways you can wear it now? right? In how many ways you can wear shirt as well as pant as well as tie, right? So these three tasks occurring simultaneously now. Again, what happens now, students? What happens? Tell me now. So it becomes what here? In how many ways I can weigh these three things now? 2 into 3 into 4. That is 2 3 is a 6, 6 4 is a 24. In 24 ways I can wear all these three things, right? So these three tasks occurring simultaneously. Got it now? And remember, students, one of the thing you have to remember here, whenever the word, right? Whenever the word and comes, right? Whenever the word and comes, what you have to do? You have to multiply it, right? Whenever the word and comes, what you have to do? Multiply it. I have to wear shirt and pant and tie and whenever and comes, what you have to do? You should multiply it. Just remember that one. Understood, students here? So this is all about what here? Multiplication rule. So in the same sense, we have addition rule also, students. In the same sense, we have addition rule. What addition rule says, right? Right? Just see. Suppose, just see. Um, addition rule. What addition rule says? Addition rule. Sorry. Addition rule. Right? Fundamental principle of addition. Right? What it is? If one of the event is occurring in m different ways and another event is occurring in n different ways, then total number of occurrence of events, either one of them, total number of occurrence of event, either one of them is given as m plus n ways. Is given as what here? M plus n ways, right? Here, there is a no simultaneous occurrence, students, here, right? Here, happening of the event, either one of them, either m can happen or n can happen. So in total possible ways of can happen, both the events is how much here? M plus n ways. Let me give you one of the example according to the situation here, right? So suppose if you have went to the hotel there to have lunch or a dinner there, right, with the family. So after having the lunch or a dinner, basically you will be having cold drinks or ice creams here, right? Suppose in the particular hotel, if they have three types of cold drinks, right? Three types of cold drinks, and they have four types of ice creams, right? So see here, after having the lunch or dinner, you have to take either cold drink or ice cream. It's one of the case here. This is the situation. You have to take either cold drink or ice cream. You can't take both the things. Got it, students here? You can't take both the things at a time here. Either you can take cold drinks or you can take ice creams, right? So in how many ways you can take, students, here? That is 3 plus 4. 3 plus 4. In 7 ways. In 7 ways you can take the things here, right? You can take one of the particular kind of cold drink, second kind of cold drink, or third kind of cold drink, or you can take first kind of ice cream, or second kind, third kind, or fourth kind here. So in total possible ways are how many here? 7. Only one you will be taking, either cold drink or ice cream, but total possible ways are how many? 7. Got it, students? And also here also one of the word, that is the word is what here? Or. Whenever the word or comes, students, whenever the word or comes, what you have to do? You have to add it. You have to add it. Right? Got it? Whenever the word or comes, you have to add. Right? You have to make the addition there. Right? Just see here. What happens here? You can take either ice cream or cold drink. Or means what here? Addition, I told you. Whereas and means multiplication, or means addition. Remember. Got it now? When you toss a coin, students, when you toss a coin, right? Let me take one more example of tossing a coin here. When you toss a coin, what is the outcome here? You may get head or you may get tail. Yes or no? You may get head or you may get tail. Total possibilities are how many? Two. Two possibilities, but outcome you will be getting only one. But total possibilities are how many? Two. Head, occurring head is one of the chance here. Occurring tail, it is also one of the chance. I told you, or comes means what you have to do? You should add it, students. You should not multiply it. 1 into 1 is 1. No. Outcome you will be getting exactly 1, you will be getting the outcome. But total possibilities of getting the outcome is how much here? 2. Got it, students? Now understood this? So whenever or comes, you should add it. Whenever or comes, it forms as cases there, right? It forms a cases, right? Whenever or comes, you should add, and whenever and comes, what you have to do? Multiply. So this is all about the two ways of principle of counting of addition by addition and multiplication. So based on these things, we have the first exercise problem, students. All are very easy. It's a very easy chapter. All are very easy, students. We can do these things, right? By knowing these two rules, we will be following the exercise, first exercise of the 7th chapter, right? Let us move on. Let us go for the problems, exercise problems, one by one, students, keeping these two things in the mind. Okay. Okay, this is the first question, students, in the textbook they have provided for you people, right? This is the first exam exercise problem, right? So now exercise 7.1. First problem, how many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of the digits is not allowed the first case, repetition of the digits is allowed the first case, repetition of the digits is not allowed the second case. Okay, so let me do this, right? Just here, how many 3-digit numbers can be formed from the digits 1, 2, 3, 4, 5? It means what here? By using these five numbers, 1, 2, 3, 4, 5, I have to form 3-digit number. I have to form 3-digit number. To form a 3-digit number, right? That too with the condition, some conditions. You can repeat the numbers in to form the 3-digit numbers, and first case it is, and second case you should not repeat the numbers in the to form what your 3-digit number there, right? Let me go with the first case, students. I have to form a 3-digit number, right? I have to form a 3-digit number whenever repetition is allowed. Just here, first case. What is the first case? Here, in the first vacant place, right? That is unit, tens, hundreds place, right? Here in the hundreds place, I can fill number 1 or 2 or 3 or 4 or 5. In how many ways I can fill the hundreds place to form the 3-digit number, right? Just here, in how many ways I can fill? In 5 ways I can fill the hundreds place, students. In 5 ways. So why 5 ways? Here, either I can fill using these 5 numbers only. I have to form the 3-digit numbers. Here in the hundreds place, I can fill the number 1, right? 1 or 2 or 3 or 4 or 5. 1 is a one single digit number, right? In one way it can be occurred here. 2 is also a number, it can be filled in one way there. 3 is also one of the number, it can be occurred in one way. 4 is also a number, it can be filled in the one way. 5 is also a number, you can fill this in the 100 place in one way there. In total possible ways are how many here? 5 ways. This is one way, one way, one way, one way, and one way. Or means what I told you, students, addition. So in total possibilities are how many to fill in the hundreds place here? 5 ways. Either you can fill 1 or 2 or 3 or 4 or 5. That is, in 5 ways you can fill the hundredth place. Now you see, when you are filling one of the element here, right? One of the number, if you are filling in this hundredth place, let me take 3 already you have filled here. And you have the liberty that once again you can use this 3 in the tens place as well as in the units place also there. Why? Because they have given the condition. What is the condition here? repetition of the digits is allowed. You can take the numbers repeatedly in this forming the 3-digit numbers there. Once you have used the number 3 here, once again you can also use in the tens as well as hundreds place also. That is the condition they are saying here, right? So once again you can use the number 3 here, right? Number 3, once again you can use it in the tens place. Now again, in how many ways I can fill in the tens place now? Here I can fill number 3 or number 2 or number 1 or number 4 or number 5. Again in how many ways? Again in the 5 ways, students. Again in the 5 ways I can fill it. Got it now? Now let me fill one of the element here, 2. If I have filled 2 in the units place, right? Again I have the liberty that once again I can use the 2 in the unit place also. You can use the number 2 or you may not. Why? They have given the repetition is allowed, right? You can use the 2 once again in the units place or you may not here. So again you can use the 2 in the units place, students, here, right? So what happens now? What happens? In how many ways you can fill in the units place now again here totally? Again you can fill in 5 ways. Either you can fill number 2 or 1 or 3 or 4 or 5. Again in how many ways? 5 ways. So by the FPC rule, that 2 multiplication rule, I have to form 3-digit number, right? I'm not forming only one of the digits here, 3 digits. This unit digit as well as tens digit as well as hundreds digit. These 3 things becomes what a 3-digit number here. And that is 5 into 5 into 5. What happens now? 5 into 5 into 5. That is 125 ways. In 125 ways, I can form the 3-digit numbers with repetition using 5 numbers, right? 1, 2, 3, 4, 5. Using these 5 numbers, I can form 125 3-digit numbers with repetition here. With repetition means here 1, 1, 1 is also included, 1, 1, 2. Here 1 is appearing thrice, 1 is appearing twice here. Where the numbers are repeated in this 125 here. Got it now? So whereas second case, let me go with the second case, students. What is second case here? What is second case? Second case. Now again I have to form the 3-digit number using these 5 numbers. Here what is the condition? Repetition is not allowed. You should not use one of the element you have used in the one of the vacant place there, right? So again I have to form what here, students? 3-digit number, unit, tens, hundreds, right? So in the 100 place, 100 vacant plates, 100 slot here, in how many ways I can fill the number here, right? Here I can fill either number 1 or 2 or 3 or 4 or 5. In how many ways I can fill the hundreds place here, students? In 5 ways I can fill the number here. Here either I can use 1 or 2 or 3 or 4 or 5 number to fill in this 100 vacant place, right? Now suppose, let me take, if you have filled the number 3 in the 100th place, right? Once again you should not use that number 3 in the tens as well as unit place here. Why? Because they are saying that repetition of the digits is not allowed. Repetition of the digits is not allowed, they are saying, students. So once again you should not use the 3 here. So how many numbers are left out to fill the tens place now? How many numbers are left out? 1, 2, 3, 4. There are 4 numbers are left out to fill the tens place. So in how many ways I can fill here? In 4 ways I can fill the tens place. What are the numbers you can fill? Either 1 you can fill, or 2 you can fill, or 4 you can fill, or 5 you can fill. Total ways are how many to fill this? 4 ways, right? Only one number you are filling it, but total possibles are how many here? 4 ways. Suppose if you have filled the number 1 in the tens place, right? Again you should not use the number 1 in the units place here. Why? They are saying repetition of the digits is not allowed. Got it now? So in how many ways you can fill in the units place? Remaining elements are how many? 3. Either you can fill 2 or 4 or 5 in the units place. So in how many ways you can fill the third vacant place now, that is 3 ways. So again, by the multiplication rule, what you have to do, you should multiply it 5 into 4 into 3, right? 5 into 4 into 3, that is 5 4 is 20, 23 is 60 ways. In 60 ways, you can uh, do the you can form the 3-digit numbers using 5 numbers, students. You can form 60 3-digit numbers using 5 numbers, that too without repetition. This is the thing, right? So just take down the answer, students, take down the solution, right? How do you write this? Let me tell you, let me give you the notes here, right? So take down the notes here. Solution, right? What they have given, I have you should write here, since we have to form 3-digit numbers, using 1 2 3 4 and 5, right? With the that to what here, with repetition. First case, with repetition. What happens now? The number of ways will be what here? Just now I told you 5 into 5 into 5 into 5 into 5, that is 125 ways, right? So you can do in the rough work also there, right? You can do in the rough work also, students. That is, I have to form 3-digit number, right? In the first vacant place, in how many ways you can form here? You can fill the first vacant place in how many ways? In 5 ways. That is, here either 1 or 2 or 3 or 4 or 5. In 5 ways you can fill the first vacant place. Next way, that is, right, with repetition. They are saying with repetition means, once again, if you have filled the number 3, once again you can fill in the number in the second vacant place as well as third vacant place. Again, in how many ways you can fill here? 5 ways. With repetition is allowed means, again you can use all these things here, right? Here also repetition is allowed means, in 5 ways you can fill the third vacant place. So by the FPC rule, I have to multiply it. So total in how many ways I can form the 3-digit number? In 125 ways, students. In 125 ways, I can form the 3-digit numbers, right? Using 1 to 5. So this is the solution for the given question. And what is the second case, students? What is the second case? Without repetition. Repetition is not allowed. Here with repetition, here without repetition. Without repetition means, I told you, if you are using one of the number in the first vacant place, that number you should not use once again in the next 2 vacant places there. So without repetition, in what way you should write here? So number of ways is equal to what happens here? What happens to this one, students? Here I told you there, right? In how many ways you can fill in the first vacant place? That is 5 ways, right? In 5 ways you can fill the first vacant place, right? Now, if suppose one of the number you have filled here, number 1, if one you have filled already in the first vacant place, that number 1 you should not use once again in the next vacant places there. So if you delete this 1, how many are left out? 4. So in 4 ways you can fill this. And if you have filled number 3 in the second vacant place, so how many are left out? 2, 4, 5. That is 3 numbers. So in how many ways you can fill the unit place there? 3 numbers. So by the FPC rule, what I have to do? I have to multiply it 5 into 4 into 3. 5 4s are 20, 23s are 60 ways. In 60 ways, you can form the 3-digit number, right, using 1 to 5 numbers with repetition, without repetition. Easy, right? So when you understand this, rest all problems you can do. Got it, students? Here it's all the problems are of same kind here, right? If you remember this problem, If you know this problem, you can do other problems also very easily, students, right? All are very easy problems here, right? Okay, so this is the thing we have to take down here for the first problem. Let me go with the second problem, students. So this is the second problem of your 7.1 exercise here. See the second problem, how many 3-digit even number can be formed, they are saying here, right? How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6. Using these 6 numbers, you have to form 3-digit even number, students. If the digits can be repeated, if the digits can be repeated means repetition is allowed, right? When the condition that repetition is allowed, I have to form 3-digit even number using 1 to 6 numbers, right? So what do you think what you have to do now, right? What I have to form 3-digit numbers, got it? That too what here, even number, 3-digit even number I have to form. So as you know, even number means what here? But 2, 4, 6, all the things, right? It may be 2 digits, 3 digits, 5 digits, any digit here. To get the even number, must and should unit place should be what here? Even, right? Must and should unit place should be what here? Even. So whereas tens place and hundreds place, it may be even or it may be odd. We are not bothered about tens place and hundreds place of the 3-digit number here. So we are bothering about only the units place, right? Why? Why? Because they are saying that we have to form 3-digit even numbers. So in the units place, I have to fill what here? Only even number, right? So what are the given numbers here? They have provided 6 numbers. They have provided 6 numbers. Using these 6 numbers, I have to form 3-digit even numbers. So in these 6 numbers, how many of them are even, students? How many of the numbers are even here? That is 2, 4 and 6. There are totally 3 even numbers they have provided. 3 even numbers they have provided. 2, 4, 6. In how many ways I can fill the units place now to get to form the 3-digit even number now, right? We are bothering about only unit place here. So either you can fill number 2 here, either you can fill the number 2 or 4 or 6. So in how many ways you can fill in this units place now, students? In 3 ways. In 3 ways you can fill the units place, that to even number, right? To get the 3-digit even number there. Understood the? Now 3, 4, 6 you can fill. That is in 3 ways you can fill the units place. Now they are saying that with the condition that digits can be repeated. If you are using the number 4 here, right? If you are using the number 4 in the units place, once again you can use the number 4 in the tens as well as 100 also. You can use the number 4 in tens as well as 100 also, or you may not use 4 in the tens as well as 100 also there, right? You may use the number 4 if you have already filled in the units place. You may use, you may not there. Okay, understood? Suppose if you are filling the number 6 in the unit place, you can use the number 6 once again in tens as well as 100 place, or also you may not use the 6 as well as 6 in the units place as well as the hundreds place there. Got it, students now? So when you are when you are filling the number in the tens place, in how many ways you can fill now? With repetition, keeping in the mind that with repetition now, here I can use the number 1 in the tens place, or I can use the number 2, right? Here there is no restriction in the tens and hundreds place. I have to fill only the even number, or I have to fill only the odd number here. There is no restrictions in these two vacant places there, right? Here I can fill the number 1 or 2 or 3 or 4 or 5 or 6, right? We can use the things here. With repetition is allowed, they are saying. In how many ways I can fill now? In how many ways I can fill? In 6 ways, right? Suppose if I have used the number 3 in the tens place, I have the liberty that once again I can use the number 3 in the hundreds place also there, right? Why? Because they are saying repetition is allowed here. If the digits can be repeated, right? Repetition is allowed. If I use the number 3 in the tens place, once again I can use here, or I may not use the number 3 in the hundreds place also. So again, once again, how many ways I can fill the number in the hundreds place now? Either 1 or 2 or 3 or 4 or 5 or 6. In 6 ways. In 6 ways I can fill the hundreds place there. So by the FPC rule, what I have to do? I should multiply it. So what happens now by the FPC rule? 6 into 6 into 3. 6 is a 36, 36 3 is a 108. So in 108 ways, I can form the 3-digit even number. There is a restriction here. I have to form what here? Even number, that too with repetition. With repetition. Got it now? Understood this, students? Now take down the notes, students, here. Let me give the notes for this one here. I hope you understood this. Right on. Solution. Since we have to form 3-digit even number using 1, 2, 3, 4, 5 and 6. That to what here? With repetition. With repetition. So in how many ways we can do this, students, here? Therefore the number of ways will be, what is the number of ways here? 6 into 3. So that is 108. That is 6 into 3. It is 108 ways, right? So you can do in the rough work also, students, here. Right? You can do this one here. I have to form 3-digit even number. Right? This should be what here? Even number. In how many ways I can do here? In 3 ways. Here in 6 ways. Here in 6 ways. 3 ways are what here? Either I can fill 2 or 4 or 6. In 6 ways means either I can fill 1 or 2 or 3 or 4 or 5 in the same sense, or 6, right? In the same sense, 100th place also with repetition they are saying. So in how many ways you can do? In 108 ways. You can, in 108 ways you can form the 3-digit even numbers. So this is all about the second problem. Now let me go with the third problem, students. Right? So third one, how many 4-letter code can be formed? Right? I have to form what here? 4-letter code. In how many 4-letter code can be formed using the first 10 letters of the English alphabet if no letter can be repeated? Right? So what they are saying, I have to form the 4-letter code. 4-letter code. Right? Using first 10 letters of the English alphabet. So what are the first 10 English alphabets here? A, B, C, D, E, F, G, H, I and J. So these are the first 10 letters of the English alphabet. A, B, C, D, E, F, G, H, I, J. Right? So these are the first 10 letters. Using these first 10 letters of the English alphabet, I have to form out here 4-letter code. Right? That too what here? Keeping in the mind that with here repetition is not allowed. If no letter can be repeated, without repetition of these letters, in how many ways I can form the 4-letter code here, students? Right? If suppose if you are using the alphabet A in the first vacant place, once again you should not use in the second, third, fourth vacant place, students. Why? Because they are saying repetition is not allowed. That is, if no letter can be repeated. Got it? This is the condition. Keeping the condition in the mind, I have to follow the this one here, counting method, right? So in how many ways I can fill the first vacant place, students, here? In how many ways I can fill the first vacant place? Here either I can fill the alphabet A or letter B or C or D or E or F or G, so on up to J there. In how many ways you can fill? In 10 ways you can fill the first vacant place, right? Only one of the letter is you have to fill in the first vacant place, but total possibilities are how many? 10. Got it? So suppose once the alphabet C, if you have used here, right? Once again, you should not use C in the other 3 vacant places there. Why? They are saying without repetition. Now, if I have filled C letter here. Still, how many letters are left out to fill the second vacant place? Remaining letters are how many here? 9, students. Remaining letters are how many here? 9. Right? Got it now? Still, 9 ways you can fill the second vacant place. 9 letters you can fill the, only one letter will be filling it, but total possibilities are how many? 9 letters. Right? Got it now? Here, if suppose if you have used the letter B in the second place, still how many are left out to fill the third vacant place now? Still 8 are left out. Either you can fill A or D or E or F, G, H, I or J in the third vacant place. Total possibilities are how many? 8. Now, if suppose if you have filled E here in the third vacant place, in how many ways you can fill in the last vacant place now to form the 4-letter code? Remaining are how many? 7. Remaining are how many students here? 7. Got it now? So in these many ways you can fill the 4-letter code here, right? By the FP rule you should multiply it, students, right? 10 into 9, 10 into 9 into 8 into 7. Got it now? So multiply this 90 into 56, right? 54, what happens now? 9, 9 6 54, right? 54, 5 carry, 9 5 45 plus 5, 50, right? 5040 ways. In 5040 ways, you can form the 4-letter code, right? You can form the 4-letter code using first 10 letters of the English alphabet. Easy, right? Very easy, right? So let me write the solution for this. Now take down the notes, students, here. I hope you understood this. Now write down the notes here. Solution. Solution now. Since we have to form 4-letter code. 4-letter code using A, B, C, D, E, F, G, H, I and J, using first 10 letters of the English alphabet. That too what here? Without repetition. Without repetition. This can be done in how many ways, students, now? Number of ways will be. What happens now? 10 into 9 into 8 into 7, right? That is 5040 ways, right? You can do in the rough work also, students. You can do in the rough work also, right? I have to form the 4-letter code, right? In how many ways you can fill the first vacant place? 10 ways. 10 ways are what here? A or B or so on up to or J. In 10 ways you can fill this. Once you have filled one of the element here, letter here, you can't fill once again in the other 3 vacant places. So still how many are left out? 9. Similarly, 8 and 7 there. Got it now? If you multiply this, you'll be getting 5040 ways. Got it, students? Easy, right? Next, let me go with the next problem, students, here. Fourth one here. Fourth one now. How many 5-digit, right? How many 5-digit telephone number can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appear more than once, right? So now you see there is a slight change they have provided here. How many 5-digit telephone numbers can be constructed? They are saying that we have to construct 5-digit telephone number. We have to construct 5-digit telephone number using the numbers constructed. How many ways 5-digit telephone numbers can be constructed using the digits 0 to 9, using the digits 0 to 9. So from 0 to 9, how many digits are there here, students? That is totally 10 digits are there here, right? 0 to 9. So from 0 to 9, using these digits 0 to 9, that is totally 10 numbers we have. Using these 0 to 9 numbers, I have to form 5-digit telephone number in such a way that they have given the condition. Form the 5-digit number if each number starts with 67. What they are saying here, condition must and should, to form the 5-digit telephone number, must and should, the first 2 digits should be what here? The number starts with what here? 67, right? The first 2 digits should be what here? 6 and 7. Compulsory 67 we should write in this. They are saying here, right? If each number starts with, to form the 5-digit numbers, each number should what have? Should have what here? First 2 digits as 6 and 7, that is 67. It should start from 67. And that too, they are saying that no digit appear more than once. Here I have used the number 6. Once again, I should not use the number 6 here. 7 they have provided. Once again, I should not write 7 in this, because they are saying no digit appear more than once, means without repetition. Without repetition, I have to form 5-digit telephone number in such a way that the first each telephone number starts with what here? 67. The first 2 digits should be what here? First one is 6 and second one is 7 then, right? Now you see, in how many ways we can do this? We can form the 5-digit numbers now. Just see here, right? Here each number starts with 6 and 7 now, right? Now other 3 vacant places. In how many ways I can fill the other 3 vacant places? Here we have already used 6 and 7. 6 is filled in the first vacant place only in one way there. They took the number 6, they have filled in the first one. In only one way they have made here. 7 also they have already substituted in the second vacant place there, right? Only in one way it can be done. So 67, it can be done in only one way. Now remaining are how many here? How many digits are remaining to fill the this one here? Vacant place, in this vacant place, third one, right? In the third place here. So here I can fill the number 0 or 1 or 2 or 3 or 4 or 5 or 8 or 9. I should not use 6 and 7 once again here. Why? Because they are saying without repetition. So in how many ways I can fill here? In 8 ways I can fill the this third place here. Got it now? Without repetition, that too without repetition, right? Here either you can fill 0, 1, 2, 3, 4, 5 or 8 or 9. In how many ways? In 8 ways you can fill. And once you have filled the number, any one of the number, if you have filled number 0 in this, right? Once again, you should not use 0 in the other 2 vacant places there. So remaining elements are how many here? Remaining elements are how many? Remaining elements are 7 ways. So in 7 numbers are remaining there. In 7 ways, I can fill the next vacant place, students. Here either I can fill number 1 or 2 or 3 or 4 or 5 or 8 or 9 if I have filled 0 in the previous one there, right? Suppose if I have filled the number 5 in the this vacant place here. So in how many ways I can fill the last vacant place now? Remaining are how many? 6. Right? Remaining are how many here? 6. In 6 ways I can fill the last vacant place, students. I hope you are understanding these all things here. Using 10 numbers, that is 0 to 9, I have to form 5-digit telephone number. To form 5-digit telephone number, that too without repetition, with the condition that each number should start with what here? 67. So in how many ways we can do? 8 into 7 into 6. 8 into 7 into 6. Why? Because 6 and 7 is already filled here. First 2 places already they have given there, right? 67. So I should take out this 67 here. How many numbers are left out here? 8 numbers are left out, students. In 8 ways I can fill this. And next, once I fill none of the number, I should not use once again. Without repetition means next will be, remaining are 7 and next 6. So total ways will be what now, students, here? 8 into 42, right? 8 2 is 16, 1 carry, 8 4 is 32 plus 1, 33. In 336 ways, you can form the 5-digit telephone number with the given conditions. Got it now, students, here? So this is all about this problem here. Let me give the solution notes for this one here. Take down the notes now. Right. Solution. You read on the solution, students? Oh, sorry. Huh. Now, I have to form, since we have to construct, since we have to construct 5-digit telephone number right, using 0 to 9 in such a way that each number starts with 67, that too comma without repetition, right? So this can be done in how many ways, students? Here, therefore number of ways will be what happens? Tell me the number of ways here, students. 8 into 7 into 6, that is 336 ways. Just now we did this. Okay, so you can do in the rough work also, students. I have to form what here? 5-digit telephone number. So each number starts with what here? 67, right? Using this 0 to 9, there are totally 10 numbers. 6 and 7 already they have filled out actually. So in how many ways I can fill the vacant place here? In 8 ways. Next, here I can fill in 7 as well as 6 ways. Okay, so you can do in this way also there, right? So let me go with the next problem, students. Let me go with the next problem now. It is a simple one, students. Here, a coin is tossed 3 times, right? They're saying that a coin is tossed 3 times. The outcomes are recorded. Are recorded. How many possible outcomes are there? Simple one, right? So a coin is, they have tossed the coin how many times, students? 3 times. First time they have tossed, second time and third time, right? So once you toss a coin, you may get the outcomes as what here? Either head you may get or tail you may get, right? If you toss second time also, you may get what here? Head or tail. Again, if you toss a coin third time, you may get either head or tail. Got it now? You'll be getting any one here, either head or anyone, either head or tail here. Only one possibility you will be getting when you toss a coin first time there, right? But total possibilities are how many? 2 possibilities. When you toss a coin first time, in how many ways you can get the outcomes here? In 2 ways. Sorry, in 2 ways you can get the outcomes. Either you can get the head or you can get the tail. Only one you are getting, but total possibilities are how many? 2, right? Again, the same coin if you toss second time here, right? Again, possibilities of getting is how much here? 2 ways. Either you may get head or tail in the second toss, right? Again, 2 ways you are getting in the third toss there. Either you can get head or tail in the third toss there. Sorry, tail in the third toss, right? So now these they have tossed the coin simultaneously, students, right? One after the other. What we have to do? We have to multiply it. One after the other they have tossed, means we have to multiply it. What happens now? 2 into 2 into 2, that is 8 ways, right? You can see in the probability chapter also that a coin is tossed 10 times. So what are the sample, how many sample points of a sample space we have? 8, right? You know that HHH, HHT, HTH. So totally 8 possible outcomes you can get when you toss a coin thrice. Total possibilities are how many? 8, right? Got it now? So let me write on this solution, right? Write on solution, students. Here, solution. Since a coin is tossed, since a coin is tossed 3 times, right? So therefore, number of possible outcomes, number of possible outcomes is what here? When you toss a coin first time, you may get either head or tail there in 2 ways. Second time, again in 2 ways you can get, that is head or tail. And again, 2 ways you can get when you toss a coin thrice, that's third time say, right? So in total possible outcomes are how many here now? 8. 2 into 2, 4, 4 to the 8. Got it now? Simple, right? Next. Last problem of the exercise, students, here. Given 5 flags of different color, how many different signals can be generated if each signal requires the use of 2 flags, one below the other, right? So read the question carefully, students, right? They are saying that given 5 flags of different colors, we have 5 different colors of flag here. 1, 2, 3, 4, 5. So we have 5 flags of different color. How many different signals can be generated? I have to generate the signals using these 5 different colors of flags. That too with the condition there. What condition they have provided? If each signal requires the use of 2 flags, right? That one below the other. One below the other, I have to generate the signals by taking 2 flags from the 5 different colors of flags. Understood this question here, students? What is the question? What they have saying here? What they are saying? I have to use the 2 flags from 5 different flags to generate the signals. In how many ways I can generate the signals by taking 2 flags from the given 5 different colors of flags, right? So in how many ways we can generate here, students, here? Now you see, that two in one below the other, one after the other, we have to generate the signals there. So if now to generate the signal, first flag I am going to choose here, right? I'm going to choose one of the flag here. In how many ways I can choose here to generate the signal? In how many ways I can do this? In 5 ways I can do this, students, right? Either I can take the first flag, second flag, or third flag, or fourth or fifth. All are out here different colors of flags. In how many ways I can take one of the flag to generate the signal there? 5-ish. First flag or second or third or four or five. Fifth flag. So in totally in 5 ways I can take the one of the flag here. So if I have taken one of the flag here, let me take second flag to generate the first signal there, and one below the other. Then below it, I have to generate again signal here by choosing one of the flag here, right? So still how many flags are left out to generate the signal, students? Still how many are left out? 1, 2, 3, 4. Still 4 flags are left out to generate the signal now. So I have the liberty to choose any one of the flag to generate the signals. That to what I have to use only 2 flags there. So total possibilities are how many? That 2 by the FPC rule I have to multiply one after these. This is the 2 tasks occurring simultaneously there. So 5 into 4, how much? That is 20. In 20 ways, I can generate the signals by taking 2 flags from the given 5 different colors of flags. Understood, students? In total 20 ways different signals I can generate it from the 5 different colors of flags by using only 2 flag, students. I hope you understood. Let me give the solution for it. Take down the solution, students. Solution. Right on here. Since we have to generate signals, right? Signals from five different colors of flags by using only two flags, one below the other, I have to take two flags, right? By taking two flags, one below the other, I have to generate the signal, students, right? So in how many ways this can be done? So this can be done in number of ways is equal to number of ways of generating the signals is equal to, that is 5 into 4, that is 20. In 20 ways you can generate the signals. In the rough work also you can do like this, students. Here one below the other we have to generate the signals by taking two flags here. So they are provided how many flags? 5 different colors of flags they have provided. In 5 ways I can take one of the flag here to generate the signal. So after taking one of the flag, still how many are left out? 4 are left out. So total ways of possibility of generating signals are how many? 20. Got it now? Understood, students? Here. So let me do, this is all about what here, exercise problems, right? This completes the exercise there. Let me do the fourth example, students, right? So let me give you the first 3 examples as a homework one, right? When you solve these 6 problems, the first 3 example problems are similar here. So go for the first example problem. It is similar to the first 6 problems there. You can do this as a homework here. First example problem you can take as a homework, right? Second example problems also you take it as a homework, students, right? It is similar to the 6 problems which I have done, right? This also, right? You take this. Now let me do the fourth one, students. It is little bit different one from the 6 problems which I have done there, right? So whereas the first example, second example, third example, you can do it, right? Just you have to do it. You take it as homework, students, and solution also they have provided in the textbook then. The first 3 worked examples. Now I'm going to do the last problem of this today's class, that is fourth worked example problem, right? So little bit different one, just see, right? Before going to solve this problem, students, you must know some basic thing I told you early itself. So whenever and comes, what you have to do, you should multiply it. Whenever or comes, what you have to do, you should add it, right? Whenever or comes, it forms as cases there, right? Now you see, go for the fourth example, last problem of this class here. Find the number of different signals. Find the number of different signals that can be generated by arranging at least 2 flags. By arranging at least 2 flags in order on a vertical staff. In order means one below the other on a vertical staff. If 5 different flags are available, right? What it says here, overall, what it says here, we have 5 different flags here, 5 different flags, right? So using these 5 different flags, I have to generate the signals. Find number of different signals that can be generated by arranging. I have to generate the signals in such a way that by arranging at least 2 flags in order, means by taking at least 2 flags from the 5 different colors of flags, I have to generate the signals now. What they're saying here, at least 2 flags. By taking at least 2 flags, right? By arranging at least 2 flags, by taking at least 2 flags, I have to generate the signals from the given 5 different colors of flags. So we have to focus on this word, students, here, at least. At least means what here? Minimum. By taking minimum 2 flags from the 5 different flags, 5 different colors of flags, I have to generate the signals. Minimum 2 flags or at least 2 flags. Minimum means you can know about this one here. Minimum means what here, students? Greater than or equal to 2, right? You come across in the linear inequality chapter, right? Whenever word minimum comes, what you have to do, you should use the greater than or equal to. Whenever maximum comes, you should use what here? Less than or equal to that. So by taking minimum 2 flags, by taking at least 2 flags, I have to generate the signals from the given 5 different colors of flags here. So what I do here, I'll be taking any 2 flags, right? I'll be taking any 2 flags, one after the other, one below the other. I'll be taking 2 flags, one below the other. I'll be generating the signals, right? And also I can take the 3 flags also, students, right? I can take 3 flags, one below the other. I can generate the signals. Why? Why? Because they are saying there minimum 2 flags you can take. They are not saying only exactly 2 flags you have to take it. They are not saying exactly 2 flags you have to take it. They are saying minimum 2 flags you can take. Minimum 2 flags you can take to generate the signals. So I wish that I can take the 3 flags there instead of 2 flags, right? So also, not only 3 flags, I can take 4 flags, students, one below the other. I can take 4 flags, one below the other. I can generate the signals. Of course, it satisfies the given condition. What they are saying, minimum 2 flags you have to take. I'm taking how many flags now? 4 flags I'm taking. Whether 4 is greater than equal to 2? Yes, I'm taking 4 flags to generate the signals. Or I can take all the 5 flags to generate the signals. Of course, it satisfies the given condition there. One, two, three, four, five. I can take all the 5 different colors of flags to generate the signals. Of course, it satisfies the given condition. What they are saying, from the 5 different flags, you have to take minimum 2 flags to generate the signals. So minimum 2 flags means I can take only 2 flags, or I can take 3 flags to generate signals, or I can take 4 flags, or I can take 5 flags. Or comes here. Got it? So in total, how many ways I can do? Right? Let me write here. Right? I hope you understood this. By taking 2 flags, only 2 flags, or 3 flags, or 4 flags, or 5 flags. You can't take 6 flags because there are only 5 flags they have provided. Right? Got it? So maximum 5 flags you can take. Minimum how much you should take? 2 flags. Either only 2 or 3 or 4 or 5. So in how many ways you can do? Let me write the solution, students. So write on the write down the solution now. Everyone here. Solution. Right? Since, right, we have to generate we have to generate signals, right, by using at least 2 flags from 5 different colors of flags. 5 different colors of flags. So this can be done in how many ways now? Number of ways is equal to. Let me draw the things first, right? So here, what they are saying, totally I have 5 different flags here. I have totally 5 different flags. Minimum 2 flags I have to choose it. And why I have to choose to generate the signals? Minimum 2 I should select it. So I can select 2 flags to generate, or I have the liberty that I can choose the 3 flags to generate the signals. Of course, it satisfies the condition. Minimum 2, they are saying. Minimum 2 flags you have to take, they are saying here. Minimum 2 means I can take 3 also there. Not only 2, exactly 2 I can take. I can take 3 there. Or I can take 4. Right? Or I can take all the 5 different colors flags here. 1, 2, 3, 4, 5. Right? Now you see. In how many ways? Now you see. So in how many ways I can take the first flag here? Like if I consider these cases, there are 4 cases here. I can take 2, 3, 4, 5. Right? So 4 cases we have here. So in the first case, if I'm taking only 2 flags to generate signals, in how many ways I can do this? 5 in first flag can be taken as in how many ways? 5 ways. Next, correct? There are 5 different colors of flags. Next, in 5 ways I can take here. So if you have taken one of the flag here, In how many ways you can take the other thing here? In 4 ways. Whether getting idea, students, here you'll be having totally 5 different colors of flags here: F1, F2, F3, F4, and F5. So in how many ways you can select the first one here? In 5 ways. Once you have taken this, still how many are left out? 4. So by taking 2 flags, how many ways you can generate the signals? 5 into 4, that is 5 into 4, that is in 20 ways. In 20 ways you can select the things, right? You can select the, in 20 ways you can generate the signals. Or means, I told you students, or means nothing but what here? Plus. So I can use 3 flags to generate signals. I told you minimum 2 means I can take 3 there. So here, in how many ways I can uh, take the flag here to generate the signals? 5 ish. How many are there here? F1, F2, F3, F4, right? F4, F5. So in 5 ways I can take one of the flag to generate the signals. If I have chosen fifth one, still how many are left out to generate a signal? 4, right? Next, if I have taken F4 then, still how many are left out flags to generate the signals? 3. Got it? So 5, 4, 3. So by taking 3 flags, in how many ways I can generate the signals now? 5 into 4 into 3 by the FPC rule, right? By the FPC rule. So what happens now? 5 4s are 20, 23s are 60. In 60 ways, I can generate the signals by taking 3 flags. Or here, if I have taken 4 flags, what happens now? 5, right? Anyone I can choose here for the first flag. For the second flag, if I have chosen fifth one, still how many are left out? 4. If I have taken fourth flag in as a second thing here, still how many are left out? 3. Next, 2. So by the FPC rule, what happens now, students, here? 5, 4, 3, 2. By taking 4 flags, I have, in how many ways I can generate the signals now? 5 4 is 20, 23 is 60, 60 into 2, 120. In 120 ways, I can generate the signals by taking 4 flags from the 5 flags, right? Which satisfies the given condition, at least 2 flags. And last case, what is the last case here? If I can take all the 5 flags to generate the signals. Why? Because they are saying at least 2 flags. It's, of course, it satisfies the given condition. So again, in how many ways I can take the flags here to generate the signals? 5 ish. If I have taken last one here, still how many are left out? 4. If I have taken F4 there, right? If I have taken F4, still how many are left out? 3. If I have taken third flag here, right? Still how many are left out here? 2, F1 and F2. And last one, 1. So in or means, I told you students, or means plus. So in how many ways you can generate the signals? So this is the thing. So what happens now? So this is 120. Again, this is what here? 120. Total are how many here? Total how much? Add it now. 120, 120, 240, 240, 300, right? 240, 300, and 320. So in 320 ways, you can generate the signals by using at least 2 flags from the 5 different colors of flags, right? So this is a different one. Whenever or comes, you should add it, students. I told you, students, here. Or means addition. So these are the total possible ways of generating the signals there, right? Got it now? I hope you understood. So this is all about the fundamental principle of counting problem, students. Just practice once at home here. Got it now? So tomorrow we'll be meeting at the same time, 4 to 5 here, with the next concept, right? Thank you. Have a nice evening, students. Sorry, madam. Sorry.